For this video, I want to show you how to run a two-proportion z-test using a rejection region decision rule. I do want to mention the fact that for the two-proportion z-test, there are some different symbols used in different textbooks, and there's also some different conditions mentioned in different textbooks. So make sure that you check your symbols and you check your conditions that they match what is in your texts. The mechanics and coming up with the results are not different. It's just that some textbooks opt to use different symbols and different conditions. All right, so let's get started. What we have is in a survey of 250 randomly selected females ages 16 to 24 who have completed high school, 72% were enrolled in college. In a survey of 200 randomly selected males ages 16 to 24 who have completed high school, 64% were enrolled in college. At alpha equals 0.05, can you support the claim that the proportion of females ages 16 to 24 who are enrolled in college is higher than the proportion of males ages 16 to 24 who are enrolled in college? All right, so one of the things that I recommend doing before you start running the test is setting up and finding the important information. And I'm going to just put it in a nice little chart just to make it easier for us to find the information when we go to do the conditions and also when we go to show out our work. All right. So with this, what we need to know for each group is the sample proportion. We need to know the sample size, and we also need to know the number of successes. Okay, and we need to do the same thing for the males, and I'm just going to denote it as a 2. This is going to be population 1, and males are going to be population 2. It doesn't matter which one you pick to be population 1 and which one you pick to be population 2. Just make sure you know which is which. All right. So the P1 is the proportion of, or P hat 1 is the proportion of females who are enrolled in college, so that would be 0.72, and we always write this as a decimal. N1 is the sample size, which is 250. X1 can be found by doing N1 times P hat 1. And you've got to remember that this is a binomial distribution because we are dealing with people that we are asking, and you cannot have a partial person, and so we can break this down into successes and failures. So when you get this, if it is not an exact whole number, make sure that you round to the nearest whole number. So for this one, it rounds exactly to 180. For the second one, our P hat 2 is the proportion of males, which is 0.64. The sample size of our proportion of males is 200. And X2 should be 0.64 times 200. So this would be N2 times P hat 2, which again, this gives us exactly 128, so I didn't have to round. If you have to round, just keep that in mind for later that you did round. All right, so our conditions that have to be met, and like I said, the conditions can be different in different textbooks. The first one is it's always important that you have random selection. So it states that samples were randomly selected. The second thing is that they do need to be independent, so males and females are independent of each other. All right, and then the one that determines us having a large enough sample size is we have to find the average of our proportions, and so the textbook that I'm using uses P bar. There are other textbooks that just call this P hat. So just make sure that you know that there is a difference in different textbooks. To find this, what we're going to do is x1 plus x2 divided by N1 plus N2. And because we are going to be using a rejection region decision rule, I do want to point out the fact that at this point right here, we are going to use P hat in our formula later to find our standardized test statistic. And if you round it at this point too much, it can throw off your standardized test statistic greatly. So I will show that to you in a few minutes. I recommend that if you do round this, round to a minimum of 4 decimal places. So 4 decimal places would give this 0.6844. Or you could leave it as a fraction. And so as a fraction, this is 154 over 225 is what it reduces to. Like I said, it doesn't matter if you reduce it this way. It's just, if you rounded this to 0.68, it's going to throw off your answer later. So I will point that out when we get to it. All right, and Q bar is 1 minus P bar. And again, some texts may do Q hat instead of P or Q bar. It's the same thing, it's just a matter of preference in symbols. Okay, so when I find this, I get approximately 0.3156, or as a decimal, 71 out of 220. As a fraction, 71 out of 225. And then what we have to do is we have to make sure that N1 times P bar is greater than or equal to 5. N1 times Q bar is greater than or equal to 5. N2 times both of these also are greater than or equal to 5. So what I would do is I would take N1, which is 250, and multiply it by the 0.6844. And I'm just going to round to the nearest whole number because of the fact that we're talking about people. And this gives me 171, which is definitely greater than or equal to 5. And then I would do the same thing with N1 and Q bar. So I would take the 250 and multiply it by 0.3156. And for this one, we end up with approximately 79, which is greater than or equal to 5. And I have seen in some texts, instead of 5, they use 10 as the threshold. So again, look at your, I don't know why there's so much inconsistency between textbooks, but just look at your textbook to verify which one yours states. And there are some textbooks that go over more that I don't have listed, and some of these that I have listed aren't in other textbooks. So they make it much more complicated for me to explain this to you. All right, so N2 is 200 times 0.6844. We can see that this is approximately 137, which is greater than or equal to 5. And N2 times Q bar, if we multiply this out, we get 0.3156. So our sample size is 200 times 0.3156. And when we simplify this, we get approximately 63 is greater than or equal to 5. So all of our conditions are met. And like I said, even if we use the 10 threshold here, we would still be able to continue because all of these are definitely greater than 5 or 10 even. Okay, so since all conditions are met, we can use the 2 proportion Z test. All right, next step is to set up the null and the alternative hypothesis. And there's deviations on this too, so there's differences between textbooks. Some textbooks have you write this all in word form. Some have you write it in symbol form. There are multiple ways that you can write this in symbol form, so I'm going to do it in symbol form, and I'm going to also give you a variation just in case that's how your text does it. All right, so the null hypothesis always comes from our claim. And so our claim is that the proportion of females is higher than the proportion of males. So we're just saying that P1 is greater than P2. And if you wanted to, you could write this as the proportion of females is greater than the proportion of males. You could write it another way that you could write this is you could say that P1 minus P2, the difference between these is going to be greater than 0. Both of these mean the same thing, and I've seen them presented this way in different textbooks. So this is our claim. The null always has to contain equality, and there are some textbooks that always only use equals here. The textbook I currently am using uses the complement, which is less than or equal to. As long as you have an equality statement in the null hypothesis, you're good. And we could have also written this that P1 minus P2 is less than or equal to 0. So regardless of the fact that our claim is about the alternative, we're going to start out assuming that our null hypothesis, the equality statement, is true. And then we're going to see, after we run the test, whether or not the evidence points towards the alternative being true, or if we should reject the null, or if we should fail to reject the null. All right, so I am going to use the rejection region decision rule. The rejection region is the easier to use method if you do not have a calculator or are not allowed to use a calculator. So if you are required to use tables to get your answers, then I advise using the rejection region decision rule. So the rejection region is based on our alpha, and the alpha that was given to us in the problem is 0.05. Okay, and what we are going to do is, because this is greater than, that tells us we are going to have a right tail test. So that means that I'm going to shade alpha equals 0.05 in the upper tail, since it's a right tail test. Okay, then we would go to our table and we would find Z naught. You can use a Z table with this, or you can use a T table. I find a T table is easier because they tell us a one tail alpha of 0.05. So we would just look at this middle row, or the middle row here, and that would tell us to look at the second column. Because we are looking for a Z score, we would go to the very bottom, the infinity row of a T test, or a T table, and that will give you the normal score. So 1.645 is the value that we would cut this off. So if we get a Z that is greater than 1.645, we would reject. If it is not in this shaded region, then we would fail to reject. So now we need to find Z, and Z is found by doing P hat 1 minus P hat 2, and then we would subtract our P1 minus P2 divided by our P bar times Q bar, and again, your text may call this P hat and Q hat, which is just the average of the two proportions from the two samples, and 1 over N2. So if I substitute in these numbers, where I'm getting these from is I'm going to go back to this table, which is one of the reasons that I write it in this format. It just makes it easier to nicely have all of the information. So we would use the 0.72 and the 0.64, and then the 250 and the 200. So we would say that 0.72 minus 0.64 divided by P bar, which is 0.6844. We could have also put this in as the fraction of 154 over 225. And I will show you in just a second. I'm going to pull up a calculator and show you why it's really important to make sure that you round to at least 4 decimal places here. All right, and then we would do the 1 over 250 plus the 1 over 200. All right, this part right here is 0 because of the fact that we're starting off with the null hypothesis, the statement being that they are equal to 0, so the difference is 0. If you had something like they believed that the difference between the two was 5%, then we would put in like a 0.05 here. So most of the time in the textbooks it's going to be 0, but sometimes our claim will actually have a numeric value, and that's when that would change. Alright, so the calculator that I'm going to use is just a free online calculator at Desmos.com. And I like this calculator because when I hit divided by, it actually puts it in fractions, so you don't have to remember to put the parentheses. If you don't have this option, just put the 0.72 minus 0.64 in parentheses in the numerator. And then in the denominator, we would do the square root. And right here is where it's really important that you use a minimum of 4 decimal places when you plug in these values. And I'm just plugging in the numbers that I have in the formula. And then I would do the parentheses 1 divided by 250. plus 1 divided by 200. Okay, and then when I hit enter, we can see that it's 1.8144. If I round to 4 decimal places, it would round up to 5. Okay, this is where I wanted to show you what happens. I'm going to actually go back up here and just copy this. Actually, it doesn't let me do that. Okay, so I'm going to go and I'm going to change this to 3.2, and I'm going to round this to 6.8. And I just wanted to show you that this is 1.8077, which does change it quite a bit. So it would still round to 2 decimal places the same, but if you do round this, it does influence the answer. Okay, if I plugged this in as the fraction, where I had the 154 divided by 225, this is going to give me the most precise answer. So the best rule of thumb in math is that if you do have things that you have to round, it's always best to keep them as exact values until the very end. So this is the most accurate answer right here, the 1.8145. The second one, when we rounded to 4 decimal places, it was the same if I rounded it to 3 decimal places. So that was just something that I wanted to point out to you that's really important. Okay, so with this, I'm just going to round it to I'm going to just go to 4 decimal places, 1.8145, because that's the first one that we got. If we would have rounded it to 4 decimal places using the 0.6844 and the 0.3156, we would have got this answer. Okay, since we're using the rejection region decision rule, what we're going to do is we're going to look at this value and see where it falls in relationship to the 1.645. Since 1.8145 is greater than 1.645, it falls in the rejection region. So this is our z-score. Okay, so since it's in the rejection region, we reject the null hypothesis. So that means that based on this sample, we're rejecting this part right here, and our evidence points towards the alternative being true. And since the alternative is our claim, when we write this down, we are going to use the word support. So we could say at 5%, there is enough evidence or sufficient evidence to support the claim that the proportion of females 18 to 24 who are enrolled in college is greater than and that should be an A. Let me erase that. Greater than the proportion of males. Enrolled in college. All right, so let me just recap what we went through. Remember that you always want to start with checking the conditions, find the null and the alternative, show your work for your formula for finding the standardized test statistic, and then if you're using a rejection rule, or the rejection region decision rule, if your standardized test statistic is in the rejection region, you reject. If not, you fail to reject. And then you always interpret back in context of the original claim. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics that you need me to cover, please let me know that as well. I know that this entire process can be very overwhelming, but just stick with it. It does get easier the more you practice.